Hello YouTube. In this video we are about to give these stones UV imaging and detecting fluorescence under UV wavelength and phosphorescence. We noticed two stones fluoresce red and orange, and the stone in the middle fluoresces a teal blue. We can see from the phosphorescence imaging that two stones remain red. We put the shortwave UV wavelength on there, and the middle stone fluoresces a teal green, very faint, but nonetheless you can make it out on the phosphorescence imaging. Here's just a wavelength LED, and this is the process of the UV phosphorescence imaging. You can see what settings I'm under the ultraviolet lamp, and what I'm going to be doing is snapping the imaging. As you can see, when I press the center screen capture, this is the phosphorescence imaging in real time. You guys can see the left corner of where the images are being taken, and this is the reaction time in real time. What's very interesting from this demonstration is that all the stones that strongly phosphoresced and the stones that also fluoresced, which was the teal green fluorescent stone, didn't have any electrical conductivity results under the conductometer. Okay, YouTube, so this stone right here was a strong red phosphorescence. This one had a weaker red phosphorescence. Now this stone that has the most amount of color is the Forever Brilliant Charles & Colvard Moissanite. This one had a faint bluish teal green phosphorescence, very slight. This stone and this stone had no fluorescence or phosphorescence, and this stone also did not have any phosphorescence or fluorescence. So in the results, when we used the electrical conductometer, we had three stones, 1, 2, 3, that was electrical conductors. Okay, so these three stones right here did not have any phosphorescence or fluorescence. They remained inert under both wavelengths. So there's three, so that's how many we had. We had two stones that were completely inert under the conductometer and did not give us a Moissanite reading or electrical conductivity meter or electrical conductivity reading. And these are the two stones that phosphoresce red. Okay, so it's indicating that there is some type of surface coating, most likely polycrystalline diamond by the chemical vapor deposition method. And this stone, we know that we can clearly see that there is some type of surface coating. We just don't know what it is, but it does give us a teal green bluish phosphorescent when we remove the UV transmission. So this is the Forever Brilliant right here, the one that has the most amount of color to it, and there is some type of coating because it picks up under ultraviolet wavelength. Okay, so that concludes the video, and this is an interesting little demonstration and observation, and I learned something from this, and hopefully you guys learned something from this, that we cannot trust these UV screeners or these portable pin probe testers. We must look at this stuff with 10x or a microscope magnification to understand that it is moissanite, and that's fairly easy. But as soon as we start getting all these other gadgets involved, we can make mistakes. But this just shows that yes, diamond material can be coated onto these stones that can fool these synthetic diamond screeners. Have a great day.